Hello everyone. Today we will solve another equilibrium problem. Here the problem states a 2500 pound wheel with a radius of 3 feet is acted upon by a force F. Figure 40, which is this one, which tends to pull the wheel over the obstruction at A. At the instant the wheel is about to move, the pressure between the wheel and the ground is 0. What is the magnitude of the force F at this instant if theta equals 40 degree? So let's draw a free body diagram for the wheel. Let's draw the major axes first. For the weight of the wheel, it will pull it downward, which is 2500 pound, and then the force F, which is acting in this direction, and the theta is this angle, and because the wheel is touching the A point, it will give a reaction to the opposite direction, and it will be through the center point. So we can write it as 3 feet, and because the height is 1.5 feet, it will be shown in here. And because it says the reaction of ground is 0, so it will not have any upward pull. So for this free body diagram, we have to find this angle. So let's solve it first. Here, sine theta of A point equals the height, which is 1.5 feet, it will act as a height, and the 3 feet radius, it will be the hypotenuse. And then we will find it by sine inverse 1.5 by 3. Therefore theta A will be sine inverse 1.5 by 3, and we get 30 degree. So this will be 30 degree, and if we assume it as alpha, and this is as beta, and this is at gamma, then if we apply the Lami's theorem, we can write it as, by applying Lami's theorem, (2500) by sine alpha, which is the angle between other two forces, equal F by sine, it will be the other two forces angle between them, so it will be gamma, and then R sine beta. Let's find out the alpha, beta and gamma angle. Here alpha equals 180 minus 30, which we have found here, minus theta, which is 40 degree as said in the question. So then we get 180 minus 30 minus 40, we get 110 degree. For beta, we get 90 plus theta, which is 40. Then we get 130 degree. For the gamma, we get 90 plus the angle of the theta A, which is this one, and the value is 30. So we will write it as 30, and then we get 120 degree. Here we need to find the magnitude of the force F, so we will work with only this portion. By applying the values, we get sine alpha, which is 110 degree, equals F sine gamma, which is 120 degree, and if we write it as F equals 2500 into sine 120 divided by sine 110, we get 2500 into sine 120 divided by sine 110, we get 2304.01 pound. And this is the answer for this problem. So that's it for today. Thanks for watching.